by the polymer melt. Here we have the cooling magnetic solenoid valves underneath the process sections that steer the heating, the cooling of the system. And again here the side feeder, and with the glass fibers being incorporated into the melt, we go to the strand pelletizing. Here is also a vacuum vent, which you can see from the back side now. Pretty interesting system, because here it's very important to get the condensate out, especially for polyamide. You know that this is a specific topic that we always have. And then here we have the strand die. Here we have the strands coming out, and this is an automatic slider. See, now you can change your production. Slide it and the bath comes underneath, and with that we can easily change products and also the cooling trough. Then the strands are cooled, brought into the cooling system. Here we have the water system for the cooling. Pretty elaborate one. Heat exchanger. And here we see the strands going up the belt. Here you see them still steaming from the water. And then they are guided into the pelletizer and cut into the little pellets, cylindrical ones. And after that we take them into a screen, and then in the vibration trough, you can see the screen. There we can take off the smaller pellets and the bigger pellets and just have the spec sizes. And then here we have the vibration conveyor, which brings the pellets up and cools them at the same time. So finally you have a very good, well-cooled and well-sized compound. Of course, we talked about the ZSE Max machines and how they have a big impact on various compounding processes. And here, for example, we have the polyamide system that we just saw. And here we can see very clearly that with an OD to ID ratio of 1.66, we can keep the melt temperature at a very good rate, and with that increase the throughput in a good way. So compared to the machines that were in the smaller OD to ID ratios, we were able to increase the throughput up to 50%, which is quite a number. Here's some other formulations, also with glass fiber, A66, sometimes 50%, and with various side feeders. And we could see almost for every case that for the ZSE Max machine compared to the ZSE HP machine, which is the 1.5 ratio machine, we always had better numbers. And sometimes it was not even possible to produce it anymore because of the high temperatures that we got. Some remarks that you might want to keep in mind. With the 1.66 OD to ID ratio of the Max machines, we have a better specific energy input, and also at the same time the cooling system is improved, which means we have lower melt temperatures, and with that we can really have a very wide process window for these systems. And with that, of course, you can run quite some different formulations with those lines. This is what the compound looks like in an electron microscope image. You can see that the little fibers are embedded in the polymer matrix in a pretty good way, which means it's a very stable compound that we have here. So when you summarize that, we have a very high throughput possibility. I've said this already, I know, with the ZSE Max. Then of course the energy savings are with that implied, because when you need lower energy input and have a higher mixing capacity, save energy. And especially for shear sensitive materials, this can be also a very highly recommended feature. So we talked about calcium carbonate compounding, we talked about glass fiber compounding. Now let's look at an interesting multi-purpose compounding line, which you can see here on this picture. Again, quite some possibilities. We're going to look at a little video just later. And with this line, we can do very different compounding possibilities, like calcium carbonate compounding. We have possibilities of two side feeders. We can inject liquids. We can bring in even a polymer from the side. We have metal separators and so on. And we have a hanging underwater pelletizing system, which enables us to walk around the line and reach it from every side. Okay, let's look at a little video that you can see of this line. Here you see the output already, and here you can see the various feed systems that are installed at this line and can be brought to the extruder with pretty easy assembly. Here you can see the picture of this line with the pre-bins. Again, we have the pneumatic conveying systems bringing the materials in the pre-bins. And we can use different materials, of course, and with that be very flexible. Here you can see 6 different materials could be brought into the formulation. And we also, of course, have a combination of gravimetric feeders that can process the formulation to your exact needs. Now let's put the various colors in. We just put the colors as symbols for various formulation ingredients. Then we bring in these various ingredients into the extruder. And then we come to the pelletizing system. Again, a little animation here. The side feeder, we can use various places for the side feeder to bring in other components into the formulation. Of course, all is controlled with one control system, which means you can control the conveying system, the feeding system, of course the extruder itself, the temperature profile, and also the pelletizing system. What you can see is a hanging one. Here you can see the shafts of the screws. And now we bring in the materials into the extruder. We melt it, mix it, and then we bring it to the pelletizer. We generate pressure, and then we have an underwater pelletizer with the water running through a water system that is constantly filtered. Here you see the cutting wheel of the pelletizer. And then finally we get another screen at the discharge of the extruder, which filters out the non-spec pellets. And then finally we have the bagging into the final silo or into bags. Okay, so with this line you can produce almost any kind of compound you want. It's very flexible, and with the ZSE Max machines, a very helpful line and very high productivity also guaranteed. And now finally we want to come to another topic, which is inline compounding. And basically we wanted to have a customer with us today from Visa. It's a big company. I think Klaus Heinrich, who is the responsible salesperson, sold a special line for this company. And Mr. Balayev wanted to be with us today, but he couldn't make it because he had very important customers come in. Automotive industry, you can already see at the beginning slide here. They are the most important customers, as you know. So he couldn't come here today. So Klaus Heinrich and myself, we want to explain a little bit how this line works then we will, I think, be done a little earlier than expected, because we all need coffee, I know, and then we will continue with another paper. But let's first look at that line. Maybe Klaus, you can come here to the front. There's another microphone.
So, Straswitche, good morning, ladies and gentlemen. I would like to introduce myself. So, my name is Klaus Heinrich, and I'm the responsible sales manager for your country, together with the company in Duko, with Mr. Zirkulev. And we would like to give you now the technical information about the inline compounding line for the automotive industry. This line is installed in Toyota by company Visa. They produce sheets to reduce the noise and the vibration in the cars.
Okay, now we have a film here, and there are Russian subtitles. I hope you can read it quickly. And let's start with the film. You can see a concept car that is also produced in Russia. And as Klaus already told us before, we can see that here we have the need of insulation.
So, as Michael told, you can see the sheets before in the cars, and this is the film to manufacture the foils continuously in a width of 2 meters. And here you can see the hopper for the premix. This was based on premix in the main feed zone. And here also some different ingredients. You see here is the compounder, it was a ZSE 87 Max in 40L over D, that means 12 barrels. Here side feeding systems, big emptying station for calcium carbonate or barium sulfate, continuously feeding by screws into the dosing units, and from the dosing units directly into the extruder. So it was a turnkey project, so we installed everything and made the commissioning very successful. It was installed in 2007 and up to now is still running without any problems. So see the screws. Drive. It's a water-cooled drive. It's a safety clutch, a gearbox from Flender gearbox, and the barrel layout. And so before to find the right screw configuration, we did a lot of trials together with the customer in our lab. This is very important and it's necessary to fulfill the quality and also the throughput. So see, here is the adapter, the die head, flat die head. From the flat die, the compound comes through the flat die head into the colander before, and there was the colander here. Here to the colander. The colander is responsible for the thickness and cooling down the material. thickness is very constant, and he can change also the dimension of the protein. Here you can see PID in principle. So we have pre-mixing with a mixing system. So the mixing station automatically, where we can fill in some polymers and also some parts of bitumen and so on. I will take or explain more about the formulation. This is the mixing station. Then we go with a container, mixing container, up into the main feeding zone of the extruder. Here. Then we have two side feeding systems where we can feed up to 80% of calcium carbonate, in this case, or barium sulfate. It's coming out of the big bag emptying station with a screw up into the side, into the dosing units, and via side feeding system into the extruder. Also vacuum is inside, and also some or a dosing unit for liquid. This was a compounding part which we supplied in 2007.
Okay, I think you've seen quite some different lines. You've seen twin screws, you've seen our technology, and of course, for some of you it might be interesting, for some of you it might be very boring, but still, if you have questions, now would be a good time for it.